So many applications require dynamic, which means real-time, X-ray imaging. This is becoming increasingly available, especially at synchrotron facilities, but it does not yet benefit from the enhanced detail visibility and complementarity information, which is provided by phase-based methods, such as differential phase contrast, which gives you neat separation between areas with different electron density, and dark field, which gives you information on the sample microstructure. We will develop a rotating wheel-shaped beam modulator in this project that will enable all the above contrast mechanisms at very high frame rate and without compromising on the spatial resolution. We will initially use this method to study molten pool dynamics in additive manufacturing processes, where we expect the sensitivity to variations in density and microstructure to provide currently unavailable information. And then we will translate it to other applications, such as, for example, dynamic vascular and lung studies in biomedicine.